In 1999, NASA launched a cutting-edge spacecraft worth $125 million. It was supposed to orbit Mars, send back priceless scientific data, and push humanity one step closer to understanding the Red Planet. But it never made it. Just before it was supposed to enter Martian orbit, the spacecraft vanished. No explosion, no communication, no debris. And the reason? A mistake so small, it sounds made up. One team used metric units, the other used imperial. That tiny mismatch, feet versus meters, crashed the entire mission. This is the story of the Mars Climate Orbiter, NASA's most embarrassing failure, and how it changed space exploration forever. In the late 1990s, NASA had a new vision: faster, better, cheaper. Instead of massive, expensive missions, they'd launch smaller spacecraft more frequently to do more science for less money. One of the first missions in this new era, the Mars Climate Orbiter. Launched in December 1998, it had a clear purpose: analyze the Martian atmosphere, monitor dust storms and weather patterns, act as a relay for future missions. It was sleek, efficient, and low cost by NASA standards. Only $125 million. The spacecraft launched aboard a Delta II rocket on December 11, 1998. Everything went smoothly. It cruised toward Mars over 9 months, executing small course corrections along the way. Back on Earth, engineers at Lockheed Martin and NASA's Jet Propulsion Laboratory, JPL, were coordinating trajectory data. That data, commands, speeds, engine firings, had to be precise, down to decimals. Mars orbit insertion was set for September 23, 1999. But behind the scenes, a small inconsistency was brewing. One that nobody noticed until it was too late. The problem began with a software system at Lockheed Martin. When reporting data, specifically thrust values, it used pound seconds, lbf.s, the imperial unit. But NASA's JPL assumed the data was in Newton seconds ns, the metric unit. The two aren't equal. 1 lbf equals 4.45 Ns. That's a 445% difference. So every tiny maneuver the spacecraft made was based on the wrong data. And over 9 months of travel, those tiny errors accumulated into a catastrophic miscalculation. And nobody noticed. Not during simulations, not during mission prep, not even after several anomalies were observed in the spacecraft's path. On September 23, 1999, the Mars Climate Orbiter approached Mars. It was supposed to dip into the upper Martian atmosphere at 226 kilometers, 140 miles, to begin aerobraking. But due to the miscalculation, it entered at only 57 kilometers, 35 miles, too low. Mars's atmosphere is thin, but not thin enough at that altitude. The spacecraft likely burned up, broke apart, or was thrown off course into deep space. NASA lost all communication. Just like that, the spacecraft was gone. No telemetry, no signal, no way to recover it. And all because of a unit mismatch. NASA launched a formal investigation. The Mars Climate Orbiter Mishap Investigation Board published a 49-page report. The root cause was officially listed as Failure to convert English units to metric units in a software file used for trajectory modeling. But it wasn't just the unit mix-up. Poor documentation, lack of system checks, communication breakdowns between Lockheed Martin and JPL, overconfidence in automation. The software had no error flag, and the discrepancy went unnoticed across multiple teams. Even when navigators noticed trajectory oddities, no one connected the dots. The failure was a public embarrassment for NASA. Headlines called it a stupid mistake, a conversion catastrophe, NASA's $125 million typo. Internal morale dropped. Congressional oversight increased. NASA had to redesign entire protocols for future missions. New policies were enforced. All teams must use SI, metric units, exclusively. Redundant verification systems added to software. Enhanced interagency communication rules. Most importantly, the event became a case study in engineering schools worldwide. The Mars Climate Orbiter became the example of how tiny mistakes destroy massive projects. Just 3 months later, NASA's Mars Polar Lander also failed, reinforcing the need for reform. But over time, NASA learned. By the 2000s, missions like Spirit and Opportunity rovers, Curiosity, Perseverance, InSight, Mars Reconnaissance Orbiter, all succeeded with improved systems. The Mars Climate Orbiter wasn't the end of NASA's Mars dream. It was a painful lesson. The crash wasn't just about math. It was about how systems fail when humans stop asking questions. Today, the Mars Climate Orbiter lives on in engineering textbooks. Companies like SpaceX, Blue Origin, and even Boeing study it as a warning tale. It proves that in the age of high technology, it's still possible to crash something because of inches versus centimeters. It reminds us, communication matters, process matters, and no one is too smart to make a dumb mistake. In the end, $125 million was lost because 2 teams didn't agree on what a unit meant. It wasn't sabotage, it wasn't bad engineering, it was just one missed detail. And in space, there are no second chances. So the next time you think a small mistake doesn't matter, remember the Mars Climate Orbiter and how it burned up in silence halfway across the solar system, all because of a number. The main problem is not the mistake. It's how many people were afraid to say, something is wrong. This is a lesson for every engineering, creative, or management team. Don't assume that others know what they're doing. Always check, even the obvious. In space, there is no undo button.